So my name is Shefali Sharma and I am the Senior Commercial Strategist at Oxford Space Systems. My background really is in engineering as well. My bachelor's was in aircraft engineering, and from there on I moved to pursuing a master's in space engineering and astronautics. So I was taken under the wings by a CEO of a mobile company, and he offered me the job, but on the business side of things. So he said, Shefali, you'll be involved in all things business, strategy, investment. But he knew my heart and soul lied with the space industry. So he really gave me that ear to go find a job if possible. If not, then I sort of commit to him and his company sort of full time, which was a very, very privileged position. And while I was there, one of my best friends, I've known her, we did masters together, was working for Oxford Space Systems. So I've been trying to keep an eye on the company, but the website hasn't yet come out at that time. So I called her up, I said, give me the CEO's number, and I called him up right away, and rest is history. So my responsibility really is to help him grow the business and set the company's strategy as we move into that commercial exploitation and scaling up phase.
So your background was kind of space engineering, and so did you design kind of spacecraft, or how?
Yes, so as a part of my thesis in bachelor, and while I was doing my bachelor, was to design a blended wing body for the aircraft. You might have heard of B-2 bomber.
Yeah.
It's a spacecraft. So I worked on the sort of the body of that. I was quite intrigued by the design, so I just wanted to explore it a bit more. So how we could improve, say, the aerodynamic efficiency of the body. So I worked on that. As a part of my final thesis, I actually worked on a program called a master's thesis called QB50. It's actually a university program, and it was like a university consortium, if you will. Quite a few universities in Europe came together to put this CubeSat in orbit, which was going to look into a few atmospheric parameters that affect the spacecraft in flight. So I worked on the operations side of things on that project. So very, very exciting. But now I've sort of moved away from engineering and now sort of found my feet and ground more on the business side of things. But that said, still an engineer at soul and love working with the engineers, but also how we can, I think what's really exciting about this position I'm working in is, engineers come up with a lot of great ideas, but how can we actually commercialize those ideas and even make money for the business, so to speak, is very, very exciting in itself. Yeah. The technology we are working on is quite disruptive. If you go really do your market research on the sort of technology we're working on, you wouldn't find anything of the sort we are doing at the moment. So it's very much seen as a disruptive, enabling technology for that next generation of satellite services we are talking about, like Internet of Things, machine-to-machine learning, satellite broadband, things like that will all be enabled due to the technology, more so antenna technology we're working on. So very, very exciting times indeed. So actually, you can imagine, as a venture capital backed business, you always have to be sort of inventing new things and looking at ideas which have a lot of growth potential, so to speak. So yes, at the moment our key focus, which is what our business plan has been based on, is antenna structures like antennas and boom systems. But that said, we are already working on sort of this next generation of even satellites, which we're calling origami sat. So it's a new way of getting the maximum surface out of a satellite when you deploy, say, an antenna in deployable panels. and even solar panels on the other side of the satellite. So it's doing away with that chunky bus in the middle and deploying the whole satellite just as panels and getting the maximum utility out of it, so to speak. So yeah, we've got a patent on that, and we are currently in a customer negotiation, very nascent, but where they love our idea and we're trying to explore it further with them.
How do you, so I guess that's for me, the origami side is quite interesting, how again that's what your team has done. You've looked at different industries, if you like, and how do you approach? Did you approach some, professionals in?
Yeah, you've got it exactly. So we don't just do it all in-house. We're very, very collaborative. Well, industry and company more so. So we actually work with the sort of industry leader, so to speak, in origami engineering, and he just happens to be just at our doorstep, Oxford University, and that's a Chinese professor, Dr. Zhong Yu. We work with, and we've worked with him since the beginning of the days, and this was also one of the concepts we worked with him to further mature. So yeah, that's exciting times. Well, how did we come up with the idea? You might have seen in recent news, companies like ICEYE, Capella Space, they're all coming up with this application called SAR, which is synthetic aperture radar. So it's about imaging Earth from space. So usually you would do that with airborne systems, but we're now trying to enable that sort of service, but through satellites. So you don't have to worry about what the sort of weather is on the day. You don't have to worry about cloud formation. You can just take, very clear, high-resolution pictures of Earth, so to speak. So all these companies are trying to achieve that, and one of the biggest sort of criteria or challenges is having a large surface area for your antenna, so it can take as many pictures as possible and can achieve whatever the mission can achieve. So that's where this idea for Origami Sat came. What if the whole satellite was an antenna and a solar panel? So yeah, that's what we're doing. We are looking sort of horizon scanning, and one of the big aspects of a venture capital backed business is to come up with new ideas and make sure there's always that growth potential, and we're always looking for new ideas.
I wonder, are you already considering maybe doing something, as we spoke with Michael before, something more local to Earth? Are you thinking of coming up with structures? I know you're focused
terrestrial.
on space. Yeah, sure.
Yeah, actually, because that's a very good question, and believe it or not, we get a lot of terrestrial interest, and reason for that is, if you look at the space environment, it's quite harsh from the perspective of, say, temperature extremes or radiation. Similar sort of environment is seen in, say, nuclear or oil and gas industry as well. So our structures will withstand forces, say, or impact, which will be seen by structures operating in that industry. So marine even. So yeah, we get quite a few inquiries. So that is also one of the routes to market but space is our key focus, and we have to deliver that for sure. But as we are growing and scaling up, I don't see why we can't, sort of venture into terrestrial markets, high-tech terrestrial markets, so to speak.
Is there anything that you would consider quite interesting for yourself specifically, or for so for me, straight away I'm thinking, okay, emergency shelters, those are the sort of kind of not obvious, but it's like, oh, okay, that makes sense. You can do
exactly
structures that deploy quickly.
Even antennas, the pop-up antennas, which the soldiers in the battlefield, they can just have those pop-up antennas in the backpack, because that's what the concept is about. Very storage efficient, very small and low mass. So you can imagine in the battlefield, when they're out and about, you can just have those antennas for comms and things like that. Even the boom systems, we I think had, a few inquiries. One of the inquiries was around having our telescopic boom system, and it was like a submarine which will even only emerge. They wanted to do the scanning of horizon scanning, whatever ships were on the horizon. They didn't want to make themselves obvious, so it was a sort of a defense security type of application. But they wanted to say use our boom system that could go up with the antenna, do the scanning, and then come back down. So things like that. I think there's a lot of overlap of technology, and hence that cross-fertilization word we talked of. So yes, we do see a lot of potential for the technology to venture into terrestrial, but it's just that's one of the challenges of a small team when the key focus has to stay with space, and how much of your resources can you actually let go of to invest in those domains is another great challenge to have, I think.